All right, dude, we are live. What's up, guys? This is Dan Keys, and today we're gonna be learning Godot. We're gonna be relearning Godot because I kind of already know the basics of Godot, but I'm still very, very much a beginner in Godot. I'm by no means experienced in it, and I wouldn't consider myself anything above beginner level just yet. That being said, I do kind of know a little bit about Godot itself, and I have played around with it. I've messed around in the editor. This was like, I don't know, 2, 3 years ago. Um, I think it's safe to say, I think it's safe to say that I've kind of forgotten most of what I knew about Godot. So it's more or less starting from scratch. So we're gonna be learning about the Godot engine, but this time we're gonna be using the Rust language instead of GD script. So we're gonna be learning how to use Rust Godot or Godot Rust. I don't remember what the um, library's name is, but we're going to be using that library and we're going to be learning that library alongside learning Rust. Sorry, alongside learning Godot. Um, Hold on. Let me switch to. Wait, I just realized that I may have forgotten something. So let me just check that something first, real quick, and then I will get back to you guys. Okay, we are good. We are good. So this is Hello World, and then there's plugin, and then there's introduction. Okay, okay. So we need to move this up. Give me a second. Move it there. Okay, then there's the step-by-step section, then there's the hello world, and I think we are good. All right, now, oh, do I need to, okay, all right. So, what was I doing? Yeah, okay, so, we're gonna be learning Godot alongside learning Rust for Godot. Also, in terms of stuff that I'm trying to learn and stuff that I'm trying to do, I earlier today I had a realization that because of the things that I've seen changing tech wise, I feel like I should pivot my studies more towards those things. So I've been seeing for the past like month. I mean, this has been a thing for uh, a year now, but like the adoption has been a lot in the past couple of months. Specifically, I'm talking about AI agents, and I was planning on getting into that. I was gonna get into it through the 5 day AI agents course. I forgot what that thing was called, specifically what the name was, but it was something along the lines of 5 day AI agents intensive or something like that. And that was meant to teach us um, all about AI agents and how to set up AI agents using an agents framework. I didn't. I mean, we started doing the that specific course, but like we didn't really finish the thing. We didn't really go past day one either. And I don't want to ignore agent based tech because it is kind of exploding right now. So I feel like I'll benefit from learning about it and also using it to build my own agent based stuff. So I decided to try and add it to my list of things that I want to do. Um, Now, though, what I'm going to be doing is I sat down and thought about this. I definitely don't want to push the content pipeline to the side because that is top priority. That is very important right now. Even if I make like a small improvement, even if I'm able to only create like version one for the time being, it's still important. I still need it. Um, Also, I think the audio interference is still there in the mic, and that is unfortunate because that it seems to be something relating to my laptop. I'm currently streaming off of a laptop, and I have my audio interface connected to the laptop via USB, and then the mic is connected to the audio interface. Um, but it turns out that apparently the shielding between the power and the USB bus isn't that great, and so it tends to pick up interference, and that kind of manifests as this. Oh, accidentally hit the weights on my mic stand. Yeah, that manifests as audio interference, and it sounds like beeping or background sound or whatever. Um, Fortunately, I do have other machines nearby, and I am willing to give them a try. I am going to be the machine on which I'm currently running Godot and the matrix rain effect and these other Tmux sessions and stuff. This machine is actually not the machine that I'm streaming from right now, which is the good news. So I am considering connecting my. I'm considering connecting. What am I? What am I saying? I'm considering connecting. What am I? What am I trying to say? Oh yeah, I'm considering connecting my audio interface to my Ubuntu desktop instead. The desktop on which I've got this Tmux session and Godot and the Matrix Rain and stuff running, where I've got my RTMP server set up basically. One challenge though here would be um, one challenge here would be getting that audio into or getting the audio signal into the VTuber application because currently it's directly reading the mic, and so it's able to get the data that it needs and do the calculations for RMS and stuff like that. But if the mic is connected, let's say I do connect the mic to the desktop and the I've successfully eliminated this interference that's going on. That's great, but what was I saying? Oh yeah, that's great, but then I need to find a way to get the signals, or I need to find a way to get the signal over to the VTuber app. More specifically, I need to manage to sync it up. And the only way to sync it up is to either run the VTuber application on my desktop, which I really don't want to do because that's going to put a massive load on the system, considering the fact that I now already have OBS and Godot and the Tmux sessions and Matrix Rain and the SRS server. I have all of these things already running. Surprisingly, I haven't been hearing the fan today. Yeah, surprisingly, it is not freaking out. It hasn't been. it hasn't been, the temperature hasn't really gone up. Something that I noticed, where exactly was that? I don't remember where that was. I think it also depends because I tend to have Discord open. I'm running Discord through the browser because I don't want to install their application. So something that I've noticed is that depending on what I'm currently seeing on Discord, so like if I'm in a Discord and I'm within a server and I'm currently looking at a channel where let's say one or two or more GIFs have been posted. Those GIFs, they're like auto playing. They're constantly playing. So if I just leave the tab in that state, I think they do consume resources. Whereas if for example, I've created like a just a blank server with my name. It's like a private server, and there's basically nothing in there except for like select few messages here and there. There's no like gifs or anything. So if I go into that kind of a server and I leave the tab in that state, then it's not consuming nearly as much as much resources. And I'm not even talking about RAM. I'm talking about CPU specifically because the CPU is the point where, or the CPU usage is the point where the fans start to complain. Oh, there is also, yeah, I just realized that I have not yet opened up, um, I have not yet opened up a Rust project here. And the moment I do that, it's going to complain. So here's what I'm going to do. I'm going to go back and make sure none of the other stuff is loaded. And yeah, just give me a second here. Okay, we'll unload this. Um, go into that. Let's unload this and unload that. Okay, right. Now, as soon as I open up Rust here, it is most likely going to complain. Oh, actually, I did not take into account the fact that um, the Rust analyzer might be taking up a certain amount of resources. This is not where I was supposed to open this project. Hold on. Let's go back here. Nope, nope. Rust project. Okay, cd into Rust. Open up new vim here. And here we have our lib. This is what we need to open. And now I need to see how much the... Oh, wait, you guys aren't able to see anything. Now you can probably see it. Hold on. Uh, the thing is gonna... Yeah, there we go. There's probably a bit of latency. So what I'm gonna do is stop this and restart it. And now we should be doing much better. Hopefully. I'm just waiting for this thing to finish loading. And I'm hoping it doesn't consume way too many resources. I want to see how big the Rust analyzer gets in terms of memory usage. Okay, it's going up to 1.1, 1.3 GB, 1.5 GB, 1.7, 1.8. Oh, did I not do the build thing? Oh God. Okay. Wait. Back up. Close this. The usage went way too high. Let me do something here. Hold on. I'm going to close this browser completely just so it frees up a ton of memory. And what else is consuming resources? So we have Godot, which is around 850 MB, around 880 MB. Let's call it 1 GB. So we have 1 GB. OBS is around 300 MB. SRS is around 300, 400 MB. Um, yeah, okay. So we have available 6.7 GB. Now, I think the first thing I want to do here is just run a cargo build. And just in case if this starts recompiling, I'm going to give it 2 cores to do its... Okay, we are good. It's done. So now I'm going to reopen this and we're going to let this thing do its loading. Okay, all right. I don't remember if I finished learning all about creating libraries in Rust, because creating binaries is something I've explored a lot. I don't remember if I've explored the creation of or well, working with libraries. Another thing I haven't explored nearly as much as I wanted to is tests, running tests in Rust. Fortunately, unlike a bunch of other languages, you actually have the testing features implemented in Rust already, so you don't necessarily need an external framework. You can very easily test your code right from within Rust. So I just need to learn that. So libraries and testing, these are two things I need to explore. Testing, I don't need to explore it in full detail, to be fair. I don't need to go into advanced stuff. I can just stick to... Hold on, I just realized I don't have my stream chat open. So let me just do that. But yeah, in terms of testing, I don't need to go into the advanced stuff, at least not yet. For the time being, I don't feel the need to go into a whole lot of the advanced stuff. Later on, as the need arises, I can learn the advanced stuff. But for the time being, just the basic stuff, just basic testing, I feel like I could benefit from it. If I do learn it, then I could benefit from it. When I learn it, then I could benefit from it. Okay, that being said, today's stream, now that we are 18 minutes into the stream, actually that's not so bad. To be honest, that's really not that bad. Oh God, the disturbance, the interference in the mic is horrible. How can I fix this? I need to find a way to get rid of this because there's only so far that I can go in terms of like noise, what do you call it, noise gating, like in term in terms of applying a noise gate. There's only so far that I can go before it just stops reading my voice, and then things are going to start to cut out. um yeah, I need to find a way around this, because my VTuber app, at least right now, it is not built to receive the audio signals over the network. It mainly receives the audio signals Well, it directly reads. It is actively recording the mic right now, and it is getting the audio signals in that way. And I can continue to do that. Uh, like I could attach another. I could attach like a phone headset, like earphones with a mic. I could attach that to the laptop and record the audio through that. But then the audio, the actual audio would be coming from the Ubuntu machine because I'm going to be connecting the audio interface to the Ubuntu desktop, and the VTuber app is running locally, and it's getting its audio signals from the the earphones with the mic, and so that might be out of sync because the RTMP feed, it has like a minimum delay of 1 or 2 seconds, anywhere between 1 and 3 seconds. So like for example, if I hit the key now, let's see when it shows up there. So there's like a good 1 or 2 seconds of delay. Um, and that delay is then also going to be applied to the mic, as in my vocals, when I connect this audio interface to that machine. And the delay is not a problem uh, as long as the VTuber app is still able to pick it up. So, okay, another thing that I could do, and this will only work this only works, or this will only work because I don't play games on stream. I don't have any other audio going on stream. That's the only reason why this might work. I could point my I could point the VTuber app towards what do you call it? I could point the VTuber app towards um, what am I what am I trying to say? I could point the VTuber app towards the system monitor instead of pointing it towards the microphone. And so when the RTMP feed comes in, that's going to play. Hopefully, that gets picked up. I don't know actually. Yeah, I don't know if that's going to get picked up by the system audio. Like, is that going to count as system audio or not? I have no idea. If I play it through a standalone VLC media player instance, then yeah, sure, it would count as system audio, and then I can capture that in my VTuber app and have the vocals take have the vocals affect the VTuber avatar. Yeah, I'll see. I don't know. For the time being, I guess we are dealing with this disturbance. I did try removing the laptop charger just to see if that helped the interference a little bit, and it did. It did help the interference a bit. Actually, quite a bit. Like in situations where there would be certain situations where the interference was just way too high, and just unplugging the laptop charger, it made the interference die down quite a bit. It didn't make it go away completely. So the interference was still there. It didn't completely go away, but a significant amount of it did die down. And yeah, that just means that I need to unplug this audio interface from this laptop and instead plug it into my desktop. Oh, I could also check if this. I don't know how this would make a difference, but I could check this if this interference also happens to show up on the Ubuntu side on this same laptop. So like in OBS on the Ubuntu side on this laptop, I haven't seen if it does show up or doesn't show up. I can check. I can find out. Oh, another thing I could do is I don't know how well this would work out. Actually, this might not work out because this is an audio interface which does pull significant amount of power. So maybe I shouldn't be plugging this into a USB hub because that hub itself is not powered right now. Anyways, okay, enough of tech troubleshooting. Let's move on to learning Godot. Okay, all right. This article is here to help you figure out. Hold on, wait. We just started, and I'm interrupting myself. Okay, the Rust analyzer takes up to 1.9 GB. All right, great, good to know. Now let me reopen Firefox over here. Yeah, so the Rust analyzer, at least for Rust Godot, the Rust analyzer takes up 1.9 GB. We can call it 2 GB. So that is how much space I need to keep in memory whenever I'm doing Rust Godot stuff. Now give me a second. I'm just loading a couple of things up in my browser. Uh, okay, all right. Great. Okay, so this article is here to help you figure out whether Godot might be a good fit for you. We will introduce some broad features of the game engine to give you a feel of what you can achieve with it and answer questions such as what do I need to know to get started. This is by no means an exhaustive overview. We will introduce many more features in this Getting Started series. Okay, cool. So, what is Godot? Godot is a general purpose 2D and 3D game engine designed to support all sorts of projects. You can use it to create games or applications you can then release on desktop or mobile as well as on the web. Great. You can also create console games with it, although you either need strong programming words. You either need strong programming skills or a developer to port that game for you. Okay, yeah. All right. For information about console support, see so and so. Okay, for the time being, I'm not touching consoles, so I think I'm good. What can the engine do? Godot was initially developed in-house by an Argentinian game studio. Its development started in 2001, and the engine was rewritten and improved tremendously since its open source release um, in 2014. Okay. Some examples of games created with Godot include Cassette Beasts, so and so, so and so, and so and so. All right, great. As an application, as for applications, the open source pixel art ga- as for applications, the open source pixel art drawing program um, Pixelorama is powered by Godot, and so is the voxel RPG creator RPG in a box. Great, awesome. You can find many more examples in the official showcase. Okay, cool. What is this? Oh, damn. That is a name. That is That is a name. Okay, all right. Then we have RPG in a box. Okay, great. How does it work and look? Godot comes with a fully featured game editor and game editor with integrated tools to answer the most common needs. It includes a it includes a code editor, an animation editor, a tile map editor, a shader editor, a debugger, a profiler, and more. Okay, great. The team strives to offer a feature-rich game editor with a consistent user experience. While there is always room for improvement, the user interface keeps getting refined. Of course, if you prefer, you can work with external programs. We officially support importing 3D scenes designed in Blender and maintain plugins to code in VS Code and Emacs for GDScript and C Sharp. We also support Visual Studio for C Sharp on Windows. Awesome, awesome. Programming language. Let's talk about the available programming languages. Um, You can code your games using GDScript, a Godot specific and tightly integrated language with a lightweight syntax, or C Sharp, which is popular in the games industry. These are the two main scripting languages we support. With GD extension technology, you can also write gameplay or high performance algorithms in C++ or other languages without recompiling the engine. You can use this technology to integrate third party libraries and other SDKs in the engine. Of course, you can also directly add modules and features to the engine as it's completely free and open source. What do I need to know to use Godot? Godot is a feature-packed game engine with its thousands of features. There's a lot to learn. To make the most out of it, you need good programming foundations. While while we try to make the engine accessible, you will benefit a lot from knowing how to think like a programmer first. Godot relies on the object-oriented programming paradigm. Being comfortable with these concepts, with concepts such as classes and objects, will help you code efficiently in it. If you are entirely new to programming, GD Quests Learn GD Script from Zero is a free and open source interactive tutorial for absolute beginners to learn to program with Godot's GD Script language. It is available as a desktop application or in the browser. Okay. Oh, this is the application that we had seen. Yeah, GD Script from Zero. Okay, yeah, yeah. Actually, we might not even touch this. I don't know. Let's see. We will provide more Godot specific learning resources in learning new features. In the next part, you will get an overview of the engine's essential concepts. Okay, cool. Okay, while this is okay, it's right. Okay, cool. This is loaded. Um, so this is about GD script specifically. Okay, in Godot, you can write code using the GD script and C Sharp programming languages. If you're new to programming, we recommend starting with GD script because we designed it to be simpler than all-purpose languages like C Sharp. It will be both faster and easier to learn. While GD script is a language specific to Godot, the techniques you will learn with it will apply to other programming languages. Sorry, zoned out. Okay, to other programming languages. Note that it is completely normal for a programmer to learn and use multiple languages. Programming languages have more similarities than differences, so once you know one, you can learn another much faster. That's true. Okay, learn in your browser with the GDScript app. To learn GDScript, you can use the app Learn GDScript from Zero. It is a complete beginner course with interactive practices you can do right now in the browser. I wonder if we should give this a try, even though I'm not planning on doing the GDScript thing. Um, and I mean, I do have a tiny bit of experience in GDScript. I have a tiny bit of knowledge in it, like very, very beginner knowledge, very basic knowledge. Uh, let's see. Let's see. Let's see what loads up here. I actually don't know what's going to load up here, so give me a second. Yeah, hold on just a minute. Let me see what loads up here. Okay, all right. The thing loaded up. It's got a nice like animation going on in it. Let me zoom out to see if there's. Oh, okay. It's like it's some sort. It's playing inside some sort of player, some sort of web player. Okay, all right. We can transition back, and we are good to go. All right. Let's see. Let's start. Oh God, I need a way to. Yeah, that was my problem. I need the text to be bigger. Scroll sensitivity, frame rate cap, we can take the frame rate down. Hopefully that helps. And yeah, we should be good. Actually, I mean, why not make it bigger then? Okay, learn to program. Learning to program can be daunting. Yet you want to make video games, so there's no way around learning to program. Every video game is a computer program telling the computer what to do. Um, Programming is the process of a game's instructions are, for example, moving so and so, so and so. Okay. All right. The computer needs exact instructions. To draw a filled circle, the computer needs to know exact drawing coordinates, the radius, the thickness, and color you want. The code to do so may look like this. Okay. All right. Awesome. Oh, we can change the code here. I don't think I can change the code. Can I change the code? No. In the following lessons, you'll learn how this code works. For now, we want to give you um, a sense of what computer code looks like. In this example, everything matters. Each parenthesis, um, e each parenthesis, capital letter, period, and comma. The computer always does exactly what you tell it to, no more, no less. It blindly follows every instruction. When you program, you're the one in charge and you're free to do anything you want. How do you give instructions to the computer? Use a programming language and precise instructions. Using prose in plain English. Okay, great, awesome. Okay, you learn to code with GD In this course, you'll learn the GD programming language. The name stands for Godot script. This is a language by game developers for game developers. This is a language by game developers for game developers. Great. You can use it within the Godot game engine to create games and applications. It's a language used by games like Dome Keeper and Brotato. Engineers at Tesla also used it for their cars' dashboards. I didn't know that. Okay, cool. GD script. GD script is an excellent language to get started with programming because it's specialized. Unlike some other languages, it doesn't have an overwhelming words, dude. Unlike other languages, it doesn't have an overwhelming amount of features for you to learn. Most programming languages are similar. Don't be afraid. Don't be afraid of being locked in. The concepts you learn, yeah, okay, cool. Yeah, so in GD script, in JavaScript, and the same thing in Python. Awesome, great. It doesn't look that different, does it? Okay, are programming languages all completely different? If you learn one language and then learn another, will you have to start from scratch? Yes, they're completely different. No, they do have similarities, yeah. You're right. Okay, great, awesome. Moving on. Okay, if you want to learn to make games or code, but don't know how, don't know where to start, this course should be perfect. We designed it for absolute beginners and so and so, so and so. Okay. Learning to make games takes practice. All right. Okay. In this course, we're not going to go through the entire course. I just wanted to get an idea of what's going on here. Programming is a skill. Okay, fine. Let's move on to practice. Try your first code. Goals. We prepared a code sample for you. For this practice, you don't need to change anything. To test the code, click the Run button below the code editor. Okay. Okay, well done. You completed the practice. Stay and play around or continue the course. Let's continue. Yeah, continue. Okay. This is teaching us both GD script and programming. And this is great, actually. This is amazing. For anyone who is completely new to programming, I think you should come check this out. And especially if you're planning on getting into Godot, then you should come check this out. They do make it easier for you to get into the programming side of Godot. I'm sure there's like interactive examples that they're going to be. Okay, hold on. Our error message. I haven't read any of the upper stuff, but okay, this is obviously like they're good. Yes, submit. Fix your first error. All right, the code is incorrect and will cause an error when you try to run it. The code defines an empty function named so-and-so. To work, the function should use the return keyword, but this keyword is currently inside a comment, which the computer ignores. Test the current code. I like that they're kind of like holding your hand. They're not just telling you, hey, figure out what's wrong here. I'm sure at some point they're going to do that, but like after teaching you, you know, how to fix specific, or after teaching you how things are supposed to be, then they're going to give you an exercise and be like, okay, there's a problem here, fix the problem. Anyways, the problem in this case is the comment. The function has to return something. Right. So we'll test the code by running, and there's an error there. Sometimes errors are reported outside of your code. Why does that happen? Indent block expected after so and so, so and so. Okay. Be careful not to remove the spacing before return. Otherwise, that'll cause another error. You may try that too if you feel like it. Oh, okay. So GDScript also uses the indent-based uh, thing, like how Python does. So that's one of the reasons why Python doesn't use curly brackets, because whether a statement belongs to a certain function or to a certain class, or within a certain for loop, or within like an if block or something, that's determined by the indentation in it. Okay, moving on. We stand on the shoulders of giants. As programmers, we rely a lot on code created by others before us. Every programming language comes with a wealth of features created by other programmers to save you time. Okay, okay. You know what? This is amazing. This is amazing. But we are going to move on to learning about the engine itself, because I'm not a beginner in programming, and I'm not planning on using um, I'm not planning on using GD script for programming in Godot. I'm planning on using Rust. Okay, overview of Godot's key concepts. Every game engine revolves around abstractions you use to build your applications. In Godot, a game is a tree of nodes that you group together into scenes. You can then wire these nodes so they can communicate using signals. There are four. These are the four concepts you will learn here. We are going to look at them briefly to give you a sense of how the engine works. In the Getting Started series, you will get to use them in practice. Okay, scenes. In Godot, you break down your game in reusable scenes. A scene can be a character, a weapon, a menu. I remember back when I was learning Godot, I got confused between a node and a scene and the scene tree. I remember trying to go deeper into it, and I just got super confused about how things were working. I was also confused about how things were working when you switched from 2D to 3D. I remember there was a very helpful person in my comments in on my VODs channel. Back when I was doing these Godot streams, there was a person who would be there to answer some of the questions that I had, and it was super helpful. That person gave me like a that person gave me like a bunch of information for questions that would arise, any sort of like doubts or something that I would have during the stream. So shout out to that person. That person also said that yeah, Godot handles 2D and 3D rendering differently, and as in there are different systems handling it. I actually don't remember completely what that person's explanation was. I just realized that. I don't remember. I'm gonna have to go back and look in my because that person had given like they had given like some good information that I can't seem to remember right now. But I do remember them mentioning that yeah, 2D and 3D are handled by two different systems apparently. And this time around, I do wanna explore that as well, because like as far as 2D and 3D goes, usually to switch you do this, but then That's rendering wise, right? I'm trying to imagine what I'm trying to connect the data side to the rendering side. Like data wise, we might have a bunch of 2D nodes, we might have a bunch of 3D nodes, but then what's happening to the 2D nodes in 3D space and what's happening to the 3D nodes in 2D space? That's kind of what confused me. And this time around, I guess we can experiment a bunch with it and kind of demystify that. Give me a second. I was playing somebody's stream just so I can have some background sound. Okay, so let's continue. Okay, in Godot, you break down your game in reusable scenes. A scene can be a character, a weapon, a menu in the user interface, a single house, and an entire level, or anything you can think of. Godot's scenes are flexible. They fill the role of both prefabs and scenes in some other game engines. Okay, all right. Okay, so in Godot, you break down your game in reusable scenes. All right. Okay, so we're just going to keep that in mind because a scene can apparently be a character or like an item in the level or the entire level itself. So if it can be the entire level, that means a scene can probably have scenes inside it. Yeah, I think a scene can, I think a scene does have multiple scenes inside it, and you can customize the behavior of each of these scenes. Okay. You can also nest scenes. For example, you can put your character in a level and drag and drop a scene as a child of it. Okay. All right. Then nodes. A scene is composed of one or more nodes. Nodes are your game's smallest building blocks that you arrange into trees. Here's an example of a character's nodes. Okay, all right. It is made of it is made of a character body 2D node named player, a camera 2D, a sprite 2D, and a collision shape 2D. Give me a second here. I'm just checking something. All right. Okay. And a collision shape 2D. Great. The nodes names end with 2D because it's a 2D scene. Their 3D counterparts have names that end with 3D. Be aware that spatial nodes are now called node 3D starting with Godot 4. All right. Notice how nodes and scenes look the same in the editor. I think this was one of the things that kind of confused me. Oh, hold on. Are we good? Yeah, we are good. It's just my Twitch app kind of bugged out. Okay, cool. We are okay. All right. Where was I? Here. Yeah, notice how nodes and scenes look the same in the editor. When you save a tree of nodes as a scene, it then shows as a single node with its internal structure hidden in the editor. Godot provides an extensive library of base node types you can combine and extend to build more powerful ones. 2D, 3D, or user interface, you will do most things with these nodes. See, there's the confusion arising again as to what is a scene and what is a node. Because if a node can have nodes inside it, and then when you save a tree of nodes, it becomes a scene, then, like, hold on. When you save a tree of nodes as a scene, it then shows as a single node. So this is a single node, and then you can customize the behavior of this node, as in you can edit this node separately, and this node will have its own behavior. But then what is a scene? I feel like as I'm doing this side by side, I should have a conversation with Gemini about this. I'm new to Godot. I'm super confused about the difference between a scene and a node. Welcome to the Godot Club. Great, awesome. Welcome, welcome to the Godot Club. It's totally normal. It's totally normal to feel a bit lost in the woods at first. The relationship between scenes and nodes is the heart of Godot's philosophy, and once it clicks, you'll see why people love it so much. Think of it like Legos versus the final model. The node is the brick. A node is the smallest building block in Godot. Every node has a specific job. One node, um, a node is the smallest. Okay, hold on. A node is the smallest building block in Godot. Every node has a specific job. One node might display a sprite. Another might play a sound. Hold on. Every node has a specific job. Okay, I need to keep this in mind. One node might display a sprite. Another might play a sound, and another might handle physics. Singular focus. A node usually does just one thing well. The tree structure nodes are organized in a hierarchy, a scene tree. A child node moves and rotates with its parent. The scene, the instruction manual or group. A scene is just a collection of nodes saved together as a single package. In other engines, you might think of a scene as a whole game level. In Godot, everything is a scene. A player character is a scene. A swinging lamp is a scene. A giant forest is a scene. Reusable. Once you make a player scene, you can drop it into a level. You can drop it into a level scene as many times as you want. Instancing. When you put a scene inside another scene, it's called instancing. Okay. Why is this confusing? The confusion usually stems from the fact that every scene must have one root node. When you look at your scene doc, you see a tree of nodes. When you save that tree to your hard drive, it becomes a scene. When you look at your scene doc, you see a tree of nodes. Okay. When you save the tree to your hard drive, it becomes a scene. When you run your game, Godot basically stitches all these little scenes together into one into one giant tree of nodes. Pro tip, if you find yourself building a very complex tree of nodes for one object, like a character with a sprite, a sword, a hitbox, and a health bar, it's time to save that branch as its own scene. Okay, hold on. See, the reason I'm confused is because um, within, no, it's because we create a root node and then a bunch of um, a bunch of child nodes within it. But when we save this entire structure, I'm assuming along with the root node, it becomes a scene. So like um, a scene is basically, no, wait. So like a scene would then contain a root node along with its child nodes, or does the scene just contain the child nodes? Okay, this is a fantastic question. This is a fantastic question and hits the nail right on the head. You've actually described it perfectly. The scene contains the root node and all of its children. You cannot have a scene without a root node. They are inseparable. Okay, okay. The bundle concept. When you save a scene, you are essentially taking a snapshot of a specific node and saying everything attached to this node and the node itself is now a single package. Think of it like a folder on your computer. The root node is the folder itself. The child nodes are the files inside that folder. Sorry, zoned out. Okay. Think of it like a folder on your computer. The root node is the child. The root node is the folder itself. The child nodes are uh, the f- are the files inside that folder. Okay, all right. The scene is the zip file that contains the whole thing. How they work together in practice. To clear up the root versus scene confusion, look at how Godot handles these two scenarios. In the scene editor, when you are editing player.tscn, you see a root node, maybe a character body 2D, and children like a sprite 2D and collision shape 2D. In this view, you are working on the insides of the package. Okay, all right. When you are editing player dot so and so. Okay, all right. So player dot tscn is the scene. The scene contains a root node, and that root node doesn't have to be empty. It can be a specific type of node, and then that can contain the other child nodes like sprite 2D and collision shape 2D. Okay, then inside the main level, which is the instance, when you drag player.tscn into your level.tscn, that entire package appears as one single entry in your tree. To the level, your player looks like a single node. The level doesn't care that there's a sprite or a collision shape inside the player. It just sees the root node of that scene. Okay, okay, all right. Why Godot does this? The reason Godot treats a saved node tree as a scene is for encapsulation. Imagine you're making a car. You create a root node called car. You add child nodes for wheel 1, wheel 2, engine, and steering wheel. You save it as a car. Now, if you have 100 cars, oh, this is kind of like a prefab kind of thing, as in the explanation is talking about prefabs. And I mean, Scenes are essentially that, right? But then, okay, that raises another question. How, so if scenes are essentially prefabs, how are you saving prefab variants? Yeah, yeah. How are you sharing? Saving. What was the word I used earlier? Creating? I don't remember what I said. Okay. How exactly are we creating prefab variants? Okay, sorry. Okay, now if you want 100 cars in your game, you don't have to manually create five nodes 100 times. You just instance the car scene 100 times. If you decide later that all cars should have a siren node, you just add it to the car.tscn once, and every single car in your game instantly gets a siren. Summary: a scene is just a saved node tree. The root node is the leader of that tree, and when you save the scene, the root and all its descendants are tucked away into that file together. Okay, so when I drag a scene into another scene, um, that child scene basically becomes a node. Bingo, you've got it. This is okay, all right. When you drag player.tscn into level.tscn, the entire scene acts like a single node within, oh, like a single node within the level's hierarchy. In Godot terminology, we say you have created an instance of that scene. Okay, then there's the Matryoshka doll effect. All right, Godot treats an instanced um, Godot treats an instance scene as a single black box, as a single back words. Godot treats an instance scene as a single black box node by default. Okay, even though your player scene might have 50 nodes inside it, animations, sounds, hitboxes, etc., the level scene just sees one node named player. Why this is a superpower. By treating a scene as a node, Godot gives you three massive advantages. Cleanliness, your level scene tree stays clean. Scene tree. I need to explore this. Okay. Your level scene tree stays clean. You don't see the guts of the player, the enemies, or the UI, just the high level objects. Encapsulation. If you change the color of the sprite inside player.tscn, every instance of the player in your level updates automatically. The scene icon. In the scene tree tab, you'll notice a little film clapperboard icon next to instanced scenes. This is Godot's way of saying, hey, this node is actually a whole separate file. Click this icon to open it and edit it. Can you still see the guts? Sometimes you do want to mess node with a specific node inside an instance scene, like making one specific enemy have a different hat. Option A, editable children. You can right click the instanced scene and check editable children. This unfolds the scene so you can see all its internal nodes within the level. Option B, exported variables. Usually the better way to write a script, the better way is to write a script on the player's root node that allows you to change settings from the inspector without opening the scene's guts. A quick mental check. Imagine you are building a house. You build a chair.tscn, root static body 3D, child mesh instance 3D. You build a table.tscn, root static body 3D, child mesh instance 3D, you drag 4 chairs and 1 table into dining room.tscn. Now, dining room.tscn has 5 nodes in its list, but each of those is actually a mini scene you built earlier. Okay, okay, hold on. So I'm trying to see if I'm getting this right. So, um, a scene contains a root node and child nodes within that root node. So basically, a scene contains a node tree. Um, is that also what a scene tree is? Wait, uh, is that right? Also, is that what is that also what a scene tree is? What else am I trying to ask here? Oh, and when I first start an empty Godot project and I'm in, no, what kind of scene am I in? Oh, when I first start an empty Godot project where under the scene tab, I guess I should say, scene panel. Under the scene panel, I'm being asked to choose a root node. What kind of scene am I in? Give me a second here. Okay, you are hitting the words. You are hitting the nail on the head. You've basically reverse engineered Godot's entire architecture in your head. Let's let's untangle those three specific points because they are the big three of the Godot logic. They're the big three of Godot logic. Is a scene just a node tree? Yes, exactly. When you save a file as a TSCN, you are saving a node tree. The root node is the entry point or the parent of everything. The children are the specific parts attached to it. The scene is the name for that entire hierarchy you saved to your disk. Is that also what a scene tree is? This is where the terminology gets a bit sneaky. There are there is a small but important difference. A scene is a template or a blueprint saved on your computer, such as player.tscn. The scene tree is the active living hierarchy that exists while your game is actually running. Think of it like this. If you have a tree.tscn file, that is a scene. When you run your game and spawn 50 trees, Godot takes those 50 blueprints and plugs them into the scene tree, the master list of everything currently alive in the game world. I think I'm confused again about the scene tree thing. Hold on, wait. Okay, what kind of scene are you in at the start? When you open a fresh project and Godot asks you to create root node, 2D scene, 3D scene, user interface, or other tools. I just noticed in my Godot editor as well that it says 2D scene. It doesn't say 2D node. For some reason, I was assuming that it's 2D node. Also, I'm curious about if this window pops up. Oh, it doesn't pop up a window. The window pops up when I do this, but are you guys able to see that window? I'm curious about that. Hold on. No, I don't think you can. Yeah, no, no, you can't. You can't see the window that comes up when I click on this plus thing to add a child node. Okay, let's undo and undo this. Okay, wait. Let's redo this and now delete this node. Does that take us back to? Yes, it does. Okay. Okay, when you open a fresh so and so, you are currently in an unsaved empty scene. Godot is essentially saying, I'm ready to make a new blueprint for you, but every blueprint needs a starting point. What kind of object is the boss of this file? If you pick 2D scene, it creates a node 2D as your root. If you pick user interface, it creates a control node as your root. Sorry, I did that popping my finger joints thing too close to the mic, so maybe that got picked up. Anyways, crucially, this empty scene doesn't officially become a scene on your hard drive until you hit Control S and give it a name like main.tscn. A final analogy to lock it in. Imagine you are writing a book. A node is a single word. A scene is a chapter, a collection of words slash nodes saved together. The scene tree is the entire book while you are reading it. While you are reading it, I feel like that's an important thing to consider. It's how all the chapters are currently glued together in order. Okay, I'm still confused about. Wait, so a scene is basically just a wrapper around a node tree that enables us to save that node tree as that enables us to save the node tree to a file. Also, I'm still super confused about exactly what the scene tree is. You are 100% correct on the first part. You nailed the definition. A scene is just a wrapper or a container that lets you save a specific node tree to a TSCN file so you can use it later. If you delete the TSCN file, the scene is gone, but the nodes are just the generic types that Godot provides. Okay, okay. Now let's demystify the scene tree because that's the part that happens behind the scenes while the game is running. The scene tree, the living map. Uh, think of think of the scene tree as the grand hierarchy of your entire running game. When you hit the play button, Godot looks at your main scene. It unpacks the scene's node tree. If that scene contains other instanced scenes like player so and so, it quote unquote unpacks those two. It glues all of them together into one single massive tree of nodes. That massive combined tree is the scene tree, the tree analogy. The scene is like a branch you've kept in your garage, saved on disk. Okay, okay. It's like a branch that you've kept in your garage, saved on disk. Okay. It has its own smaller twigs, nodes attached to it. The scene tree is the whole tree growing in the yard. when the game starts. What? No, is the scene tree is the whole tree growing in the yard. When the game starts, Godot takes all those individual branches from your garage and grafts them onto the main trunk. Okay. Okay. Why this distinction matters. In your code, you will often see get tree. This is you asking Godot to look at the entire living game, not just the local scene you are currently working in. Common things to do with the scene tree. The big boss. Change levels. Get tree.change scene to file. Pause the game. Okay, quit the game. How to see it for yourself. This is a light bulb moment for most beginners. Next time you run your game in Godot, look at the scene panel on the left. While the game is running, you'll see two tabs on the top, remote and local. Click remote. Okay, let's try that. How do we play? Can we play right now without a root node? Also, where's the play button? I forgot how to do stuff here. Um, yeah, how do you run the scene in Godot? Editor, project. I've completely forgotten. Hold on. Is there like a button that I'm Oh, there it is. Sorry, I couldn't see in the top right because my I have something blocking my screen. Okay, yeah, it's in the top right. Okay, no main scene has ever been defined. Select one. You can change it later in the project settings under the application category. Okay, let's select I do not have a scene. Okay, let's add a node 2D. I still do not have a scene. I need to save a scene. I need to save something for it to run. Okay. All right. Okay. So it said, what did it say? Yeah. Okay. Remote and local. So are we currently in local? We are currently in local. Click on remote. Okay. The remote view is the scene tree. You will see things there that aren't saved in your files, like bullets you've spawned, enemies that haven't, enemies that have been that words, enemies that have been duplicated, or the main loop nodes that Godot uses to run the game engine. Okay, so yeah, I see root here. I don't see that necessarily over here. I see root over here. That's interesting. Okay, okay. Wait, let me close this running instance and then we can get back here. Okay, so the scene tree basically only exists during runtime. This is a runtime representation of the entire application that's currently running. Also, if we have 5 instances of um, enemy of an enemy scene in there, um, does that mean that there are 5 different enemy node trees being created in the scene tree? Also, what would be considered the root in a scene tree? You are on a roll. You have officially cracked the code of Godot's architecture. Every one of those assumptions is spot on. Okay, let's break down your specific questions because they lead directly into how you'll actually code your game. Does the scene tree only exist during runtime? Yes, precisely. Editor time, you're looking at scenes, individual scenes. Runtime, Godot creates the scene tree. It is the living, breathing state of your game. When you close the game window, that specific scene tree is wiped from memory. Okay, if you have five enemies, are there five node trees? Yes. When you instance a scene, Godot essentially performs a copy paste operation in memory. If your enemy scene has a sprite 2D and a collision shape 2D, and you put five of them in your level, the scene tree at runtime will contain five separate enemy tree nodes. Each of those each of those will have its own sprite and collision children. This is why you can kill one enemy without all of them dying. Each one is unique. Each one is a unique live version of the same blueprint. What is the root of the scene tree? This is a point of minor confusion for many. There's a difference between your root node and the scene tree root. When you look at the remote tab while the game is running, you will see a node at the very top, usually called root. This is a special node called a window or viewport. Okay, the system root is the ultimate boss of the engine. The system root. This is the ultimate boss of the engine. It handles the game window, the screen resolution, and the main loop. You don't touch this. You don't usually touch this. Your main scene, your main or level scene, is actually a child of that system root. The path to victory. Because everything is one giant tree at runtime, nodes can talk to each other using node paths. Imagine your player wants to tell the scene tree to restart the game. The player has to climb the tree to talk to the boss. The player node says, "I need the scene tree" using get tree. The scene tree says, "I'm the manager. What do you need?" The player node says, "Restart the current scene." Okay. Okay, so even within the scene tree, there will usually be one um, root aside from the system root. Yeah, there'll usually be one root scene, right? Because it seems like Godot needs at least one scene to load into. So I'm assuming if you're loading, so I'm assuming usually you would be loading one scene into the scene tree, and that scene can then have an entire root, an entire, yeah, let's say root structure set up. You have officially mastered the Godot mental model. You've nailed exactly how the engine breathes. Yes, Godot requires a main scene to kick things off. Without it, the engine would just be an empty window with nothing to render. Okay, all right. The main scene, the entry point. In your project settings, you define one specific TSCN file as your main scene. When you hit play, Godot creates the system root, the viewport slash window. Godot instantiates your main scene. Godot attaches your main scene's root node as a child of the system root, the root structure, quote unquote. Your main scene is essentially the anchor of everything else. Because a scene is just a node tree, your main scene can be as simple or as massive as you want. The simple way, your main scene is just level one. It contains the tile map, the player, and some enemies. The pro way, your main scene is a global manager. It contains a UI layer, a music player node, and a level holder node where you swap different levels in and out. In both cases, your main scene's root node becomes the top level node of your game's logic, a visual breakdown of the handshake. Think of it like a theater production. Project settings, the stage manager is choosing which play to perform today. The main scene, the master blueprint for the entire stage layout. The system root, the physical stage itself. Wait, the master blueprint for the entire stage layout. Okay. The system root, the physical stage itself. The scene tree, the actual performance happening right now with all the actors in their places. Okay, one final thing, singletons, auto loads. Since you're thinking about the scene tree so clearly, there's one cheat code Godot uses. Sometimes you want a node like a score tracker to stay alive even when you change the main scene from level 1 to level 2. In Godot, you can create auto loads. These are special scenes that Godot attaches directly to the system root besides your main scene, beside your main scene. Um, this way, when you tell the scene tree to delete level 1 and load level 2, auto load stays exactly where it is. Okay, all right, and let's say I let's say I have a level manager scene and a level 1 scene. When level 1 is loaded from the level manager, since level 1 is its own scene, um, does it does it load um, does it load beside level manager in system root, or does it replace level manager? Um, does system root limit how many um, scenes can be loaded? I don't think it would, but I kind of want to understand how the scene tree is working. So like maybe okay, this is exactly where game architecture begins. How you handle this depends entirely on how you tell Godot to load the scene. In Godot, there isn't a hard limit to how many scenes can be loaded into the system root, but there are two very different ways to handle the transition. The clean swap, if you use the command get tree.change scene to file, Godot looks at the system root, it finds your current main scene, it deletes the level manager, which is the main scene, and everything inside it. It installs level 1 as the new child of the system root. Okay, the result, level 1 replaces level manager. The manager is gone from memory. Okay, the second method, the nested approach, side by side. If your level manager is designed to hold levels, like a frame holds a picture, you wouldn't replace it. Instead, you would make level one. Oh, yeah, okay. That's one method. That I was words. Hold on. I was aware of that possibility. Like, okay, you have the level manager, and then within the level manager, you load the entirety of level one. Okay, right. You create a level holder node, just a basic node 2D or marker inside your level manager. Via script, you instance level one. You use add child to attach it to the manager. Result, the level manager stays alive, handling UI, music, and global timers, and level one sits inside it. Does the system root have a limit? Technically, no. The system root is just a container. You could theoretically attach 100 different scenes directly to the system root if you wanted to. However, standard practice is to have one active scene structure, active scene tree structure. If you have five scenes loaded at once, but they aren't connected to each other, it becomes very hard for them to talk to one another. Analogy: the system root is like a power strip. You can plug you can plug in a TV, a lamp, and a toaster. Okay, TV is level manager, a lamp is level one, uh, and a toaster is UI. They all get power, but they don't necessarily know the others exist unless you specifically wire them together. Which should you choose? Use replacement for simple games where the main menu is one world and level one is a completely different world. Use nesting if you want a persistent manager like a HUD that never disappears, or a loading screen that sits over the level while it loads. The pro secret auto loads. Okay, yeah, the singleton thing. Okay, cool. Wait, so um nodes. Wait, hold on. Wait, so hold on. I need to present a scenario to Gemini and ask it to explain how this would work out. Wait, so let's say I have level manager, level one, and level two as their own scenes. I load I wait, level manager is loaded into system root. Um, and but then I also have the choice to load level 1 and level 2 alongside, not inside, alongside level manager. However, they would not be able to interact with each other. Whereas if level 1 and level 2 were loaded into level manager, all three would be able to talk to each other. Also, could you go into what system root is again? Because I want to get a proper idea. Because so far, what I'm understanding is that the system root is basically just a container in which the rest of the application is being loaded. So that container, we can think of it as the window or the viewport. and then everything else that functionally does something is being loaded into that. Okay, you are asking the exact right architectural questions. This is where you move from making a scene to building a game system. To answer your first part, yes, they can technically talk to each other even if they are side by side, but it's like trying to yell to a neighbor across the street instead of talking to someone in the same room. Side by side versus nested. The talking problem. In Godot, nodes talk to each other using node paths. If level 1 is inside level manager, level 1 can just say get parent to talk to the manager. It's a direct, reliable link. If it is beside level manager, both under system root, then level 1 has to climb up to the system root, then look back down to find the level manager. The problem, if you ever rename level manager or move it, level 1's code will break because it can't find its neighbor anymore. What exactly is the system root? The system root, often just called root in code, is a special window node, specifically a window or viewport class, created by the Godot engine the moment the app starts. Think of the system root as the operating system for your game. It's the boss. It manages the actual window on your computer screen, the borders, the X button, the resolution. Okay, all right. Manages the actual window. Okay, all right. It's the invisible container. Where was I? It's the invisible container. You can't see it in your local scene tab because you didn't build it. Godot provided it. You can't see it in your local scene tab because you didn't build it. Oh, okay. It's built during runtime. Godot is providing it. Okay. All right. It's the tree trunk. Every scene you create is just a branch that eventually has to be plugged into this trunk to get power and appear on screen. Note in GD script, you access this quote unquote boss by typing get tree.root. Okay, the stage analogy to clear up the loading. Imagine a physical theater, system root, the actual theater building, level manager is the stage. It stays put for the whole night. Level 1 and 2, which in this case I'm guessing are loaded inside level manager, not alongside it. These are the scenery. If you put the scenery on the stage, nesting, the stage manager can easily, what's the stage manager here? I don't, wait, okay. The stage manager can easily move the scenery around. If you put the scenery in the lobby beside the stage, so side by side, oh, wait, so this is on the stage versus beside the stage. The actors on stage can't see it, and the audience can't see it. Okay. How loading usually looks. When you want level 1 to start, you usually do this inside your level manager script. Okay. Load the file, load so and so, instance it, unpack the box, okay, instantiate, and then add it to the tree. So we first load the resource, we then instantiate the scene, and then we unpack the scene. No, I'm assuming instantiating does unpack it. So we instantiate it, thereby unpacking it, and then add it to the tree using add child. Because you called add child from inside the level manager, level 1 is now officially inside the manager. That's what she said, or giggity, or whatever. That sounds weird. Anyways, so does the idea of the system root, yeah, okay, that clears it up. So we can move on to, man, holy shit. I think I just solved my entire confusion that I had the first time around when I was learning Godot. Holy shit, dude. Shout out to Gemini. Okay, right. Notice how nodes and scenes look the same in the editor. When you save a tree of nodes as a scene, it then shows as a single node with its internal structure hidden in the editor. Godot provides an extensive library of base node types you can combine and extend to build more powerful ones. 2D, 3D user interface, 2D, 3D or user interface. You will do most things with these nodes. Awesome. Okay. Oh, dude, I think this was the one. Hold on. This should be visible on stream, right? Even though the browser window is small, I just need to check if yeah, this is visible. So there's a window thing here. There's also a sub viewport thing here that I'll look into later. But there's a window thing here. So I'm wondering if this means, because I do remember this being a thing. I believe you can actually launch multiple windows. Yeah, I think you can actually launch multiple. Hold on. Beneath this, there's a scene tree thing. Okay, hold on. So, all your game's scenes come together in the scene tree, literally a tree of scenes. All your game's scenes come together in the. Okay, all right. Okay. So, here, right. And as scenes are trees of nodes, the scene tree also is a tree of nodes. But it's easier to think of your game in terms of scenes, as they can represent characters, weapons, doors, or your user interface. I feel like the fact that they called this the scene tree, as in the way that they mention scene tree here, it kind of confused me. I think this might have been my confusion the first time around, because even now they're calling this the scene tree. Okay, I've noticed a bit of ambiguity in the term scene tree. Because here, when we talk about a scene tree, we are talking about something that only comes into existence. It could also be that I understood what was being explained in the documentation wrong, as in what was being words what was being explained in the documentation, I understood it wrong. That's a possibility. We are talking about something that only comes into existence during runtime. But I've also noticed the docs. Okay, let's read this again. All your game scenes come together in the scene tree, literally a tree of scenes. But I've also noticed in the docs it is mentioned all your game's scenes come together in the scene tree, literally a tree of scenes. And as a scenes, what? And as scenes are trees of nodes, the scene tree is also, the scene tree also is a tree of nodes. You've spotted a classic piece of documentation speak that trips up almost everyone. You're absolutely right. The term scene tree is used in two ways, which makes it feel like a moving target. Let's clear up that ambiguity by looking at the two lives of a scene tree. The literal scene tree at runtime. This is what we discussed earlier. Because I feel like what's being mentioned here is the node tree As in the docs, what's being mentioned is what we've been discussing and calling a node tree, and they are using node tree and scene tree synonymously, because of which there's a bit of ambiguity there. I don't know if they are meant to be used synonymously, or like, is there some confusion here on my part, or if there was a mistake in. I don't think it's a mistake in the docs, definitely. I don't think so. But like, I'm wondering if there's like, I don't know. Okay. The literal scene tree runtime. This is what we discussed earlier. When the game is running, there's exactly one scene tree. It is the active living hierarchy that includes the system root, your main scene, and all its children. No need for the analogy. Okay. The conceptual, the words, the conceptual scene tree, the structure. When the docs say the scene tree also is a tree of nodes, they're talking about the logic of how Godot is organized. Because every scene is just a tree of nodes, you can put scenes inside other scenes, and you can put scenes inside other scenes. The entire project, even when it's just files on your hard drive, is conceptually one giant tree structure. Holy shit, dude. Okay, the docs are saying a scene is a tree. A scene inside a scene is just a branch on a bigger tree. Therefore, everything in Godot is just one big recursive tree structure. Understanding the nesting. When the docs say it's a tree of scenes, they mean that your hierarchy looks like this: root, which is system root; main scene, which is the root node of main; then player scene, enemy scene, and so on. Okay. Why the ambiguity exists. The word scene is both a verb and a noun. How is it a verb? Okay, the verb, the hierarchy currently being processed by the engine. That's an interesting way of looking at it. That is an interesting way of looking at it. Okay, the scene tree class, the thing you access with get tree, is the manager that handles the logic of this hierarchy. It's the glue that allows a node in one scene to find a node in another. One final check on your system root question. If you look at the remote tab, the scene tree, while running, you'll see root, your main scene, and so, which are the children of the main scene. Does this help reconcile why the docs call it tree of scenes and tree of nodes, and a tree of nodes at the same time? It's all the same tree, just viewed at different levels of packaging. I think I kind of get it, maybe. I think so. I'm going to stick with what Gemini explained to me just for the sake of not getting just horribly confused. I also just noticed that I still have the Python logo on my stream. I knew I was forgetting something. I, I, I had a doubt that I was forgetting something. I think for the next stream, what I'll do is I will, I think I do have the Godot logo saved from their like branding package. So I'll put that Godot logo on, and yeah, maybe the next stream will also be this, because dude, I've been, hold on, let me go back to this thing. Yeah, I need to sit down and work on this list. So far, this is what I've got. As I was going down the list and I was looking into various agent frameworks in Python and Rust, because I definitely want to learn this tech. There's a lot to explore here. So I do want to learn the tech, but I want to try and do this locally, which is going to be a bit challenging. So like, I don't want to use an LLM. I want to try and use like a smaller model. something that maybe responds to very specific instructions, and I'll build something very limited with that. The thing is, agents, they usually tend to involve LLMs. But like as I'm learning this, as I'm going through it, I need to try and find a way to not involve LLMs, or maybe involve like a very, very, very super duper lightweight LLM that maybe doesn't do the best in terms of conversation, but it can follow instructions very well and give output in a structured manner very well. Okay, then what's next? Signals. Right, this is their sort of event system. Uh, okay, nodes emit signals when some event occurs. This feature allows you to make nodes communicate without hardwiring them into code. This feature allows you to make nodes communicate without hardwiring them into code. Okay, it gives you a lot of flexibility in how you structure your scenes. Okay, all right. Signals are Godot's version of the observer pattern. You can read about it here. I'm definitely going to look into that. For example, buttons emit a signal when pressed. You can connect a piece of code to this signal, which will run in reaction to this event, like starting a game or opening a menu. Other built-in signals can tell you when two objects collided, when a character or monster enters a given area, um, and much more. You can you can also define new signals tailored to your game. Summary: nodes, scenes, the scene tree, and signals are four core concepts in Godot that you will manipulate all the time. Nodes are your game's smallest building blocks. You can combine them to create scenes that you can then combine and nest into the scene tree. You can then use signals to make nodes react to events in other nodes or different scene tree branches. After this short breakdown, you probably have many questions. Bear with us as bear with us as you will get many answers throughout the Getting Started series. Okay, all right. This this was great. This was actually great. This has been super productive. Give me a second here. Hold on. Okay, hold up, hold up. Where was I? I was here and here. Uh, Yeah, you know what? Okay, we will go to this person. Um, what is their name? Sinea, I think. Sinea? Sinea. Yeah, people have a problem with my name as well, like pronouncing my name all the time as well. So like I get that feeling. I guess we'll find out once we once we go to this person's stream and they pronounce their name. That being said, yo, we've had a productive stream. I need to continue. I don't think I'm gonna continue learning Godot off stream. I'm gonna continue learning it on stream. Off stream, I'm gonna continue working on my content pipeline. I need to finish that sliding window functionality. After which, I will then be able to feed content into a language model or any other NLP focused model. Because for the language model, I still need to use one of those libraries to force the model to give structured output, and I haven't explored that library yet. I should add that to the list, by the way, that I need to explore that library, because otherwise I'm not going to be able to use any LLMs for that purpose at all. Okay, that being said, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.